Hi, this is Narasimha here. In this video, I will check how to find whether linked list contains the palindrome data or not. So I have taken an example of a linked list with 5 nodes. So it has the palindrome data. So considering the palindrome data is this is the first node and this is the last node. So when we traverse from first node to the last node, or when we traverse in the reverse direction from last node to the first node, the data has to be same. If a linked list contains such data, then we call it as that linked list is palindrome. So if you can observe that, so first node is 60, second with 70, third with 80, fourth with 70, and fifth node with 60. And if it travels in the reverse direction, the data also is going to be same 60, 70, 80, 70, 60. So if the data is same in the both directions, in forward and reverse direction, then we call it as it's a palindrome in linked list. So we have to, in the given linked list, we have to identify whether the given linked list is contains palindrome data or not. So coming to the approach, so this is the problem statement. We have to identify whether the linked list contains the palindrome data or not. Coming to the approach to solve this problem, there are many solutions to solve this problem. So one such solution is solving it via recursive approach. So what we do is that, so for simplicity, for tracing purpose, I have taken some 3 nodes here, which is having the palindrome data here. And so what we do is that, so we'll traverse each node one by one till it reaches to the null by calling the recursively the method. So once we reach to the last node with null, so we'll stop or break calling recursively that method. Okay, and as we have traversed till the last node, so we have the information with respect to the last node. We somehow we have to compare with the first node data. So the first node data with the last node, and similarly, let's say if it is lengthy one, then second node data with this node, and once we reach to the mid node, anyhow the data is going to be same. So this is what we have to do. So first, so somehow we have to compare. So we have last node data information here, first node data. We have to just what we can do is that we can create some temporary node object reference, and we can create this one temporary node and initialize with the first node. Okay, and so now we have the information of first node data as well as the last node data. We will compare like first node data, that is 60, is it equal to the last node data with 60? Okay, and moving on to the next one. So before moving on to the next one, so whatever this temporary node is pointing to the first node will point to the next node. So how do we do that? So we'll write like temp node dot link. So that is going to point to the next node. So in each node, it is going to have two things. So one is it's data or information about the node, and second one is link or object reference or address of the next node. So using this link or next node object reference, so what we can do, we can traverse to the next node. So for example, this is the head or first node. So when I'm going to say head dot link, so it is going to point to the next node. Similarly, so as we are initialized with the temp node with the first node data, so when we are going to say temp node dot link, so that is going to point to the next node. Okay, so this is an high-level explanation. So we'll just go through this in detail. So what I'm going to do is that, as we have decided to solve this problem via recursive approach. So let me just take this one. So we'll create a one method like is linked list palindrome, and it is going to accept the first node of the linked list. So as we are solving this via recursive approach, I'm just writing the same method name here. Okay, so when we call this one, we are passing the first node details here. And next, when we call this method second time recursively, so we have to traverse to the next node. So how do we do that? So as the node, we are passing the first node. So when we say node dot link, so that is going to point to the next node. So this node, we are passing the first node. Okay, and when we make it node dot link, so that's going to point to the next node. So probably we'll just do it in the right order. So right now, so when we call first time, so one more thing is that whenever this method is called, so each method call is going to be get stored in stack, and so we'll just see that as well. So when I call first time is linked list palindrome, and I'm passing with the first node, so this is going to be stored in the stack. So let me make an entry in the stack. So in the stack, it creates a new frame, and it just stores it here. So as the node data, when we are going to call first time, so this node data is going to have as 60. So first node is having the data 60. So I'm just marking here as 60. And next time we are calling one more time, this recursively is linked list palindrome with node dot link. So when we say, so right now we are pointing, our node is pointing to here. So our node is pointing to here. And when we say node dot link, so that is going to point to the next node. So our right now our node is in it is pointing to the second node. So, as soon as we call this one, so one more entry will be stored here in the stack with node is equal to. So now our node is pointing to the 70. So I will just write it as a 70. Okay, and we have to call this recursively this method until we reach to the null. So till that we will keep on calling this recursively this method. So again we will call this method is linked list palindrome, and so when we say node dot link, so right now it is pointing to the second node. So when we say node dot link, so it is going to point to the next node. So I will just write here as of now our node is pointing to this third node. So now our node value becomes equal to 60. Okay, and we have not reached till null, so we'll call it one more time. So again, we'll call this is linked list palindrome with node dot link. So this is the node, and which is point. This is the link. So when the currently it is pointing to the null, indicating that there are no further nodes in the linked list, and this is the end of the linked list. This is the last node basically. So we'll call this one more time, and now this node value is equal to now null. So now we have reached the end of the linked list, and we have to stop calling this recursively method. So otherwise, this is similar case that we have to put as a base condition up to what extent we have to call this recursively this method. So once we reach this null, we'll put a condition if this node value is equal to null, we'll just write a return statement so that it is going to break or stop calling this recursively this method. So this is the similar case with for loop or while loop. So we will be writing a condition inside a loop that up to what extent that iteration has to be run, loop has to execute. So if you're not going to write a condition, so then it is going to run infinitely. Similar case here also, we have to write a particular condition until what extent this recursively it has to call. So now, in case if you have not written it, it is going to throw exception or error. It ends up with that one. So as we have reached end of node, we'll just write that we have reached at the end of node, and we'll just write a return statement. Okay, so now I will just make some note here as it is pointing to node equal to null. So next step is when we say return with the condition if, so that is going to now the execution control will goes to the shifts to the previously called method that is with is linked list palindrome with node data is equal to 60. Now our now we have the last node data that is 60. And we will just compare this one with the first node. So for this first node, we'll create some temporary node, and we'll initialize with the temporary node with the first node. Okay, so once we initialize with the help of temporary node, we'll compare. So this temporary node data 60, is it equal to the whatever we got from the stack frame node data is 60, so which is pointing to here, which is pointing here. Okay, so maybe we'll just write here. So right now our node data is pointing at the last node, and we have initialized with the temporary node data at the first node. So here we'll compare temporary node data, which is pointing to the first node, that is 60, is it equal to the last node data 60? Okay, so if it is equal, so just make it some flag, and your nodes data are matching, and we have to move on. So now before we go to the next one, so we have to point our temporary node to the next node. How do we do that? So we just say temp node dot link so that it will point to the next node. So well, just right now our temporary node is pointing to second node. Okay, so now from the stack, so what does it happen is that so it has done its job. So node data with 60, and it calls back to the next previously called method with node data is equal to 70. So now with the node data 70, so our node data, this is going to point at here. So with the mid node. So now both temporary node and node both are pointing to the mid node. And again, we'll be doing the comparison. So temporary node data that is 70 is equal to the node data, which is equal to 70. So both are 70. And again, same thing. So we'll point our temporary node. So temporary node to the next node. So with the instruction like temporary node dot link. So now our temporary node is pointing to the last node here. So again, so from stack frame, so it comes to the previously called method that is the node data is equal to 60, which is pointing to the first node, right? Now again, the comparisons will be made. Node data that is 60 is equal to the temporary node data 60. So if you have observed here is that, so again, we are comparing one more time with the last node and first node, so we can just avoid it. So once temporary node and node both reaches to the mid node of the linked list, so we can just stop stop comparing the nodes data, which is a duplicate effort. So if you observe initially, so temp node we initialize with the first node, and node data which was already pointing to the last node, we have already done a comparison whether the node data is equal or not. So again, it is not required to compare. So once we reach to the mid node, we can just stop, and we'll conclude that the given linked list is a palindrome. Okay, so before we go for coding, so one more thing we just need to look into that. So here, if you have observed, I have said that each time once it has done its job, it is calling previously called method with node data 60, and previously called, once it's done with node data 60, this one again it goes back to the previously called method with node data with 70. So what is the meaning of previously called method here is that this is a bit confusing here. Maybe the method names are same, but if you have just looked at clearly, so it is quite understandable. So we'll just check in a minute. Let's say there is a method XYZ and ABC. So what I will do is that in the XYZ method, we are calling ABC. So in ABC, we have just written a simple instruction to print ABC. And also in XYZ, once it executes ABC, next statement instruction is to print just XYZ this to print. So actually, how does it happens? Or if I want to show it as in stack representation, so let's say from main method, I'm going to call this XYZ method. As soon as it sees this XYZ method in the stack, it is going to be stored as this XYZ method. Okay, now the execution control is going to shift to this XYZ method. And inside this one, it looks, there's one more method, ABC. Now the execution control shifts to ABC. So now again, it registers this ABC method in the stack. Okay, so now in the execution control, it comes to ABC method. Here we have instruction just to print just ABC. And we don't have anything inside this. And what does it do is that the execution control shift backs to the previously called method XYZ. So this is what. So once ABC has done its all job, so it is going to the execution control. It goes back to the previously called method XYZ. In XYZ particularly, it starts executing this statement XYZ. Right. This is also like the similar way. Once ABC it has done its job, so it will be called. It goes back to the previously called method XYZ. Similarly here also. So once here we have not written anything extra logic here. So we are just traversing each node in this one. Once it's done, reaches to null. So we are telling that we are writing a return statement. Then it goes back to the previously called method node data with 60. So that's similarly here also. So once you look at here at XYZ, so here also it just prints this XYZ, and with respect to XYZ method, there is no further actions or instructions are left over here. Now execution control will shifts back to the previously called method that is main. So this is where we started calling this one, right? So that's what we are trying to do here. So it goes back to the main. Similarly, each method which will be done with its set of instructions, it goes back to the previously called method. So this is what like previously called method, how it is going. It is a similar way, but only thing here is the method names are same. That's why we might see it as a bit confusing, but it is not. It is executing as usual flow. Okay, so we'll just see how to code it. So we'll create a method is linked list palindrome. Okay, so as we are going with recursive approach, so I will write just the same method name here, and this is going to accept first node of the linked list. Okay, so now we are going to call this method recursively until it reaches to the last node that is null. So how do we do that? With node.link. Okay, so once we reach to the last node with null, so we'll put a condition. So to break or stop calling recursively this method, if node equal to null, so we'll just say that return. So return true. So this is a Boolean. So either we have to return true or false. As of now, I'm passing true. If logic requires changes here, so we'll come back and change the return statement here. Next step is once we say with return, once we reach to the node is equal to null. So we'll just say return, and it points to the node data with 60. And we have to compare first node data with the last node. And for the first node data, we'll create a temporary node, and we'll initialize with the first node or head of the linked list. So we'll create one temporary node. and we have to initialize with the first node. So for that, so I have created already a method which will create a linked list based on the data whatever we're passing in terms of array. So I'm passing a 60, 70, 60 as palindrome data, and it creates 3 nodes, and it returns back to us as first node of the linked list. So we have this first node head, so we'll initialize the temp node with head. Okay, now our temporary node is ready with first node. We'll compare first node data, is it equivalent to the last node data? So we'll come back here and we'll just check temp node data, temp node info, whatever it has, is it equal to node info? So if it is equal, if the node data is matching, then we'll create a flag here. So is node data matching? So as the node data is matching here, temporary node info equal to node info, then we'll set this value with true. Let's say if it is nodes data are different, then we'll set this flag with false. Okay. Okay, so next is we have done the comparison, first node and last node. We'll point temporary node to the next node by writing temp node dot link. Okay, so we have pointed to the next node temporary node, and this flag will return it. So this will be written to this one. So here, one more case we need to handle it. So let's say the first node data and last node data as of now, it is matching. If it is, let's say if it is not matching, it is 60 and it is 100. So clearly 60 is not equal to 100. Now we have already have the result that the given linked list is not a palindrome. So in this case, what we can do is that we need not to go further comparing like a temporary node to point to the next node, and again comparing taking the stack node data from node is it equal to temp node. Basically, if the data is not matching, so we need not to execute all these set of instructions. So for that, what we can do is that so we'll create one more flag which this method will receive. Okay, so this method will receive this flag, and let's say if the data is not matching, a case where 60 is not equivalent to 100, so last node is 100, then we have already have the result that the given linked list is not palindrome. So what will we do is that so we'll put a one condition here. If this flag is false, we'll will return false. So by returning false, what does it happen is that so it will not execute the remaining all of this set of instructions. So let's say the node data here is not matching, and our intention is to should not go further to match this node with temporary node, whatever is there in this one, and maybe here the second node data with this one, right? So we have done first node last node comparison, which is not matching. So it is not required to go second with this node. It is not required to match as we have already have the result. So that in order to do that, we have here only put a condition to return false. So what happens is that as soon as this flag, it will be received as false as the node data is not matching. So we are checking is it equal to false. If it is equal to false, then it will simply return false. This method again receives the like flag value as false, and again it checks is it false. Yes, it is again false. So what does it happen is that in this one, for each method whichever it is calling previously called method, it keeps on sends the value as false, and it doesn't execute all the set of instructions which are not required. Okay, and this is the one thing. And second thing is that one more condition we need to handle here. So once we reach to the mid node, as we have seen that, so again this temp node we are pointing to the next node, and from the stack trace this will be executed as which will point to the first node, and we are comparing first node data with last node. So you can keep it as it is, but if you just want to remove the duplicate effort, so once we reach to the mid node, so we can put some logic here. Do not like compare the next upcoming nodes and point to this temporary node to the next one. So what we do is that once temporary node and our node from stack trace, if it is pointing to the mid node, so we can just write that. So first the data has to match, so mid node data, and we will put one more condition. So temp node equal to node. So that means both are pointing to the mid node. So when temporary node and our node, if it is pointing to the same node, that is, if both are pointing to the same node, that means they are at mid node. So that's why we are just we have to stop this one at mid node. So that's why we have written like temporary node is it equal to node. So what we do here is that, so we'll just print a message here. So linked list is palindrome. Is palindrome. So one case to handle this is that I can throw some exception to stop this one. So I can create runtime exception, and by saying that we are at mid node, we are at mid node, and no need of going further the comparisons of node by throwing this exception. So what we are trying to say is that once it reaches to this mid node, it compares the mid node data, and later, so this temporary node, whatever we are pointing to the next one, and which will be pointing this previously called method that will point to node dot node is equal to 60. So it will not execute. It throws an exception by saying that we are at mid node, and given a list is palindrome. So if you are not interested to throw an exception. So we have to write some logic here. So if you're not interested to throw exception here, so what we can do again, we can just write a simple thing here as return false. So once it reaches to the mid node, so once the data is matching both nodes data, so we can just simply write return with false. So what does it happen? So this method will receive the flag as false. And again, next statement is that is this flag is equal to false? Yes, it is false, and it keeps on and it returns false, and this is again receives the flag as false. So only this set of instructions will be executed. And also our intention is to not to execute all these things from post reaching to the mid node. So this is also one way that we can handle. So if you just look at this one, so once we reach to the mid node, if I'm going to send false, so what does it happen to that? So all upcoming, once it reaches to the mid node, all upcoming calls it sends as false, and also we don't want to compare the node data here. So it will just send the false value. But by doing this logic, we have one more thing here. So as we are sending always false, even if it's the data in the linked list is palindrome, then also we are sending the value here as false. And if the data is not palindrome, then also we are sending false. In both the cases, we are sending false. So we should not use basically it's sending in both the cases as false. So what we can do as a smaller change, so we can create one more flag as a result and set it as false initial value. And once it reaches to the mid node, and we'll just reset this result flag. This result boolean, whatever variable is there, will set it to true by saying that the linked list, whichever is given to us, we have examined, and it is palindrome. So in our main method, wherever it is, we are calling this one. So we have to just use this one with this result value instead of whatever the outcome comes from this method. So basically, what I'm trying to say, so when we call this from somewhere from main method here, so this method always returns as false value. So do not consider that one. So basically, once we call this method, consider that whatever we have created global variable. So take that result value. If result, so if result equal to true, just print a message that the given linked list is palindrome. Else print a message as it is not a palindrome. So I hope this is pretty much clear. I'm stopping at right now. Thanks everyone.